Gupta from ID Roorkee, and we will be continuing discussing our top interview 150 series of questions on Leetcode. And our today's question is uh, symmetry tree. So let's go to this question and see what it states. So this question states that given the root of a binary tree, check whether it is a mirror of itself that is symmetric around its center. So this is example number one given to us. This is a tree one. Its left child is two, right child is two, then three, four, four, three. So we have to check whether this is symmetry around this line or not. So 2 and 2 they are equal, 4 and 4 they are equal, and 3 and 3 they are equal. So there is a symmetry, so we'll return true in this case. In example number 2, again we will draw this line. 2 and 2 they are equal, but for 3 there must have this 3 must have been on the left child of this second node. Then the symmetry would have been there, but there is no symmetry along this mirror. So hence we will return false in this case. Constraints are the number of nodes in the tree is in the range 1 to 1000. So total nodes can go, as in this tree there are total nodes 5. So total range can go from 1 to 1000, and node dot value can go from minus 100 to 100. Here values are 1, 2, so these values can go from minus 100 to 100. So I hope you have understood the question. So let's directly see the explanation how we are going to implement it. So first of all, we will check for the root. If root is equal to null, then we will return true. Because if this is an empty tree, then there is already a symmetry. So we'll return true in that case. Otherwise, we will define one function, and like we will pass its left child and its right child in that function. And then inside that function, we will check what is the value of if root 1 is equal to null and root 2 is also equal to null, then we will return true. But if one of them is null, then this means that like there is no symmetry, so we'll return false. And we'll also check if their values are not equal, then this also means that there is no symmetry, and hence in this case we'll return false. Otherwise, if false is not returned till now, then we will pass root 1 dot right and root 2 dot left, because we want to compare these. So we will pass right of root 1 and left of root 2, and similarly left of root 1 and right of root 2, because we want to compare its left and its right. So we will make use of recursion, and this is how the solution will go. Let's go to the code, and then we will better able to understand how this is working. So this is the definition of binary tree node: struct tree node, int value, tree node star left, tree node star right, and then there are various constructors. We are given this function bool is symmetric tree node star root, and we have to implement this function. So first of all, we are checking if root is equal to null, then we'll return true. Otherwise, we are using this function as symmetry root dot left, root dot right, and we are returning whatever this function will return. Let's come to this function. So this is tree node star root 1 and tree node star root 2. First of all, we will check if both of them are null, then we'll return true. If one of them is null, then we'll return false. If their values are not equal, then we'll return false. Otherwise, we will check, we will pass this root 1 dot left and root 2 dot right, because we want to compare left and right. And then again we will pass root 1 dot right and root 2 dot left. If both of these checks are true, then only we will return true, otherwise we will return false. So this is the code, and let's try to run it and see whether it's working fine or not. So this is getting accepted here. Let's try to submit it as well. So it is taking time. Yeah, it has given accepted solution. So this solution is working fine. I will attach this code solution in the comment section of the video, and I will also attach this problem link and problem description in the description of the video. So like this video and subscribe to my channel for more such top into 150 series of questions on Leetcode.